All right, so 5.4 talks about inequalities for sides and angles of a triangle. You've already learned that if you have congruent angles inside of a triangle, then the sides opposite those angles are also congruent. So you're going to learn something else about, well, what if you don't have congruent angles? You can still figure out which is the largest side and which is the smallest side, just by looking at angles, and vice versa. By looking at sides, you can figure out which is the largest angle and which is the largest or the smallest angle. So here's theorem 5.9. If one side of a triangle is longer than another side, the angle opposite the longer side, bless you, and this is not an angle marker, this is a greater than, sorry. So I specifically put an arc mark in here. So the angle opposite the longer side is greater than the angle opposite the shorter side. I will look at a couple of those examples here in a minute. Is that fuzzy or is it just me? I'm convinced that half of you need reading glasses because you always tell me it looks fine. Maybe that's better. All right. Then theorem 5.10 says if an angle of a triangle, and this is a greater than sign, is greater than another, the side opposite the greater angle is longer than the side opposite the lesser angle. So this just does the reverse. It talks about how can you tell which angle is bigger or smaller. You look at the sides. Don't quit kicking the table there, Katie. If you want to tell which side is bigger or smaller, look at the angles. I think I can move this over. Give you more foot room. Bless you. And then theorem 5.11, I've put a picture with it. The perpendicular segment from a point to a line is the shortest segment from the point to the line. And isn't that also how we determine the distance from a point to a line? That perpendicular segment? In addition to that, it's also the shortest distance. So it's your true distance. And the whole point of this is that if you have a perpendicular segment, if you have two segments going from one point, like on this picture, if you have two segments coming from T and touching the line LR. The fact that TR is perpendicular to the line and TL is not means that TR has to be the shorter side. And this also brings us into Pythagoras Theorem. You'd have a right triangle, and any segment out of the three that's not perpendicular, in other words, that one's a hypotenuse, it's always the longest side anyway. And the last thing before we do some problems, corollary 5-1. The perpendicular segment from a point to a plane is the shortest segment from the point to the plane. It's basically saying the same thing as 511, only we're talking about a plane versus a line. It's tagging on to what theorem 511 says and says it's the same thing in a plane. A corollary is a statement of fact. There's no formal proof behind it. It's just kind of like, well, if this is true, then logic reasoning says that this is true also. Theorem has a formal proof behind it. A postulate could have a formal proof behind it, but it doesn't. We just know we could do one, but we haven't. We know that we could, but we haven't. Can I take it away? Anybody opposed? Yeah. Okay, I'll wait. About broke my foot on that back then. Now can I take it away? Okay, so I want you to look at this example here. Whoa. Get it up here and then freeze it. All right, so as you look at this picture, it says name the angles with the least and greatest measure in triangle ABC. So this is logic reasoning on some of this, and you'll see why. It looks like the longest, in this entire picture, it looks like the longest side here is CD, wouldn't you agree? That does not mean that angle CBD, this angle right here, is the longest angle in the entire picture. This is or largest angle. This is the largest angle in just that triangle. So it doesn't work for a quadrilateral, only for a triangle. So if you look at ABC, what's the longest side? CB, right? So what's the largest angle? Angle A. Isn't angle A the largest angle? According to this, according to our theorem, angle A should be the largest angle because it's across from the largest side. So what would be the smallest angle? We can't call this B though, right? Because there's two angles associated with it. What do we call it? CBA. So angle CBA is less than, you have to use inequality signs to show their order. So this is the smallest. What's the middle angle? C, but you can't call it C, so what are you going to call it? ACB, okay. So angle ACB is less than, what's the biggest angle? So then I can call that angle A, right? So that's from smallest to largest. If they asked you to go from largest to smallest, it'd just look like this, but in reverse, and you'd use greater than signs. So that's for ACB. And then it says name the angles with the least and greatest measures in BCD. So let's look at this one. So what is the smallest angle? Angle D. So angle D, because it is across from the smallest side. What's the medium angle? C, but we can't call it C, so what are we going to call it? BCD. So angle BCD is less than, what's the largest angle? CBD. Now they don't ask this here, but, oh, they're not going to ask on this one. I'll show you one out of your book here in a minute. So there's that, and then we're going to do, let's look at one like this, and then I'll move to the one question I have in the coordinate grid. Where'd my pen go? Okay, this is a good one. So if you get a question like 3 and 4, name the value of x, and if you're not writing this down, you should be. Name the value of x and list the sides of triangle PQR in order from shortest to largest so the angles have the indicated measures. So I'm going to do number 3. And that is not my good pen. Where's the good pen? Aha. So I'm going to draw a picture of a triangle. I have no idea what kind of triangle it is. I don't know if it's acute, obtuse, right? It really doesn't matter. So we've got PQR. And then they said angle P is 7x plus 8. Angle Q is 8x minus 10. And angle R is 7x plus 6. They're asking us to order the sides this time. Before we order the angles, this time you're going to order the sides. How can I order the sides if I don't know what? In order to order the sides, what do I have to know? The angle measures. How do I find the angle measures? I really don't have them, right? All I have is expressions. What do I do? Yeah, add them all together and set them equal to 180. So 7x plus 7x is 14x. What's 14x plus 8? 22x. And then 8 and 6 is 14. What's 14 minus 10? So plus 4 equals 180. So this is all of these added together. Subtract 4 from both sides. And then divide by 22. Does 22 go in there evenly? Look at 176. What's 1 plus 6? See how 7's the middle number? 11 goes into 176. How many times does 11 go into 176? 11 goes into 17 how many times? Huh? Once, with 6 left over. How many times does 11 go into 66? 6. So that reduces to 16 over 11 goes into 22 twice, and doesn't that reduce to 8? So I didn't have to do any long division on that. So now I know that x is 8. What do I do with that? Plug it into each one of these. So what's 7 times 8? 56 plus 8. Plus 8. 64. So that one's 64 degrees. What's 7 times 8? 56 plus 6. 62 degrees. And 64 minus 10, 54. What should I do? Should I double check and make sure that they add up to 180? I would. 60 and 60 is 120, plus the 4 and the 2 is 126. Is 126 and 54 180? Yes. So it appears that we have a correct solution for the angles. So we had to go through all of that just to find the angle measures. Now can't we order the sides? So if they want the sides ordered from shortest to longest, what's my shortest side? What's my smallest angle? Q. What's the side opposite Q? So it's PR is my shortest side. You see how that's the side opposite? So I want PR to be my shortest side. So that's less than. It's R. Then what's my middle angle? R, right? That's the next biggest. So R is across from what side? PQ is less than, and then this is my biggest angle is P, right? P is across from what side? QR. So this is the actual answer that they are looking for. All right, so two different types. Then we're going to do on the coordinate grid and we'll be done. Okay. Oh, good gracious. Sorry, people watching the video. Now we're all askew. Okay. Example, this would be what, 3 by now? So example 3 says draw triangle JKL with vertices J is negative 4, 2, K is 4, 3, L and L is 1, negative 3. List the angles. In order from least measure to greatest measure. So I need a coordinate grid that's a 4 by 4, don't I? So we're going to plot those points. J is negative 4, positive 2, bless you. K is 4, 3. And then L is 1, negative 3. And you want to connect those points. None of the lines are specifically or exactly horizontal or vertical, are they? And if it almost looks like an equilateral triangle, doesn't it? You can't assume anything. So how am I going to order the angles? What do I have to know in order to order the angles? The side lengths. How do I find the side lengths? Yep, distance formula. How many times do I have to use the distance formula? You've got to use it all 3 times, unfortunately. There's no way around it. The other thing that you're going to run into, what if I gave you 3 ordered pairs and I said, do these ordered pairs make a triangle? Okay, the no-duh answer to that would be, well, graph it and see, right? Well, what if you're not allowed to graph it to prove it? If I give you 3 vertices and ask you, does it make a triangle? So you might want to write this as a note, as an aside, as a different type of question. You have to find the slopes of all 3 sides. So you'd have to find the slope from, J to K, from K to L, and from L to J. You have to find all three slopes. If all three slopes are different, won't they at some point form a triangle? Okay, you haven't even plotted it, but that's how you can tell without plotting points if you have a triangle, without graphing it. All right, so we are going to find the distance of each side. So the distance from J to K is equal to. So go ahead and just start plugging into the distance formula. You have to know what the distance formula is first, and there is our template. Do you hear it? Do you hear how big that thing is? Don't you hear it?
That's disgusting.
Yes, it's waddling. Those of you on the video, that was a great big squirrel or rat going up over the roof. The ceiling. It's still here because we were so quiet. See, if y'all were a little noisier, that thing would not come out. All right. Oh, now that I'm shivering. Oh, nasty. All right, so from J to K, if I label these x sub 1, y sub 1, x sub 2, y sub 2, they are going to change with each pair that I do. So I'm not going to actually do that, but make sure that you're putting the y's together and the x's together. So this is the difference of the y squared and the difference of the x's squared. So here I'm going to take 3, which is a y, and subtract the other y, which is 2. Then I'm going to take the 4, which is the x, and subtract the other x, which is a negative 4. In some instances, like this one, you're going to have to add the opposite. So plus plus. And then don't drop off your radical, because then some of you forget to put it back in. So I've got 1 squared plus, this actually gives me an 8 squared. And all you have to do, I'm not even asking you to simplify the radical. Leave the radical unsimplified. Don't I have 1 plus 64? Square root of 65. So and it's a lot easier if you don't simplify the radical. So if I were you, I would put from J to K the square root of 65 here. Do not simplify it. It's a lot easier to compare radicals when they're unsimplified. All right, do it again. The distance from, let's do K to L. All right, so my y is 3, and my other y is negative 3. My x is 4, and my other x is 1. So add the opposite, and I end up with 3 plus 3 is 6 squared, plus 4 minus 1 is 3 squared, which gives us 36 plus 9. What is that? 45. So in by KL, I'm going to put the square root of 45. So when you compare these two, which side is longer? The JK, because 65 is bigger than 45. All right, last one for the sides. I'm going to do L to J. Let's pick the distance from L to J. And do make sure that you are choosing a different length each time, that you don't do the same length twice. So my Y, I'm going to do the 2 first this time, and then the negative 3. And then the 1 minus the negative 4. It doesn't matter which comes first in here, to be honest. So add your opposite. You end up with 2 plus 3, which is 5 squared, and 1 plus 4, which is 5 squared, which gives you 25 plus 25, which is the square root of 50. So the square root of 50 goes here. Now I can order my angles. So which, and they want you to go from least to greatest, which is my smallest angle? Yeah, because it's across from my smallest side, right? So angle J is less than, what's my middle angle? Yep, 50 is across from K. So angle K is less than, and then that leaves angle out, right? Done. Any questions about that? Okay.